we were doing triangles.
And the 14th one we are starting.
Yes, so few questions are remaining in this exercise. So have we completed 14th or not?
No, we are starting.
Yeah, 2 questions were remaining. Okay, fine. Okay, so question number 14th. Yeah, it's again a good question, Martin. Just
Okay, ma'am.
practice it well, huh? All right, so that's the figure. A, B, C, P, Q, R. Now side AB and AC and median AD, right? So that's a median. That means BD is
Yeah.
equal to DC. And okay, ABC are respectively proportional to side this. Show that, okay. So it is given. First of all, it is given that D is a median. So that means BD is equal to DC, right?
Okay.
And also it is given that M is a median. So that means QM is equal to MR, right? This thing is given. Then it is given
Yeah.
that side AB is proportional to PQ. So AB upon PQ is equal to, then you have AC upon
PR.
PR, yes, and equal to median AD
AD
by
upon
PM.
PM.
Okay, this is given. Now you have to prove that triangle ABC, the complete triangle, is similar to triangle PQR. Okay, now see the complete triangle is given similar. All right, Martin.
Okay, ma'am.
So if triangle is similar, that means the sides are proportional, right?
Yeah.
So these two conditions are already given. I mean, because the triangles are similar, but the third
Yeah.
one is actually about median, right? Not about the triangle.
Oh, okay.
Yeah. So we, sorry, a triangle we have to show similar. I'm sorry. So if we have to show similar, so I need to get something like this, that AB by PQ is equal to AC by PR is equal to the third one, BC by QR. So if I get all the sides proportional, so that means S criteria is satisfied here, right?
Yeah.
But there is some problem. So instead of the third side, I am given the median. So my
Oh.
approach will be to change this median into the third side. Understood?
Oh, okay.
So that's what we will try to do. So to do this, in this question, we will do one construction, Martin.
Okay.
I'm sorry. Because we want to use midpoint theorem here. Okay, so we will draw a line DE which is parallel to AC like this, and similarly we will draw a line here which is parallel to PR. Understood? So construction
Okay.
here is this, that draw DE parallel to AC and MS parallel to PR. So that's the construction. Okay, then now you come to triangle ABC. Now, what is the midpoint theorem? So if you revise that, you have a triangle, for example, ABC, right? And
Okay.
yeah, so if D is the midpoint, let's say, right? And this line is
Okay.
parallel to the third one. So what does the midpoint say? Midpoint say that it will divide AC also at the midpoint. That means E will also be the midpoint. Understood?
Yeah, ma'am.
So that's what we will use here. So in triangle ABC, now it is given that D is the midpoint of BC.
Okay, ma'am.
So one midpoint is given, right? And then it is given. And we have drawn DE parallel to AC. So two things are there, right? By
Yeah.
construction. So by converse of midpoint theorem, E is also the midpoint of AB. Right?
Okay, ma'am.
By converse of midpoint theorem. So you have studied this theorem in class 9th. Right?
Okay, ma'am.
Now, same thing we will do in other triangle. But okay, before that, one more thing we should do here. So, okay, let's stick to ABC only. So D is the midpoint. So that means I can write that DE is actually now E half of AC, right? Because E is the midpoint we have proved.
Yeah, ma'am.
Yes, okay. Now, similarly in the other triangle, so we will not repeat the whole process. We can write similarly. We can write that SM is actually half of QP. Understood?
Yeah, ma'am.
So Martin, you have not asked me one question.
Yeah, ma'am. What happened?
Yeah, why I have written DE is equal to half of AC? Because I have got
Because the midpoint
no, E is the midpoint of
is AB.
AB, right? And I have written DE is equal to half of AC. Why?
Ma'am, because it's like the midpoint and
Hmm. D is the midpoint of what? AB, right?
yeah, ma'am.
So DE should be uh, I'm talking about DE. I'm not D is the midpoint means BE is equal to EA, isn't it?
Yeah,
This is what the meaning of the midpoint, but I'm not writing this. I'm writing this that the length of this line DE is half of AC. From where I'm writing this? Anything you remember from class 9th?
yeah. That midpoint.
Midpoint theorem actually, right? Now,
Yeah,
this was actually by converse, right? Now by midpoint theorem was that if this line was parallel and they both are the midpoints, then actually this line is half of the third line, right?
okay.
Please, like, you can just revisit that theorem. So from where I'm writing this, there I'm writing, right, by midpoint theorem. So D is actually half of AC. The theorem says, and this actually is a half of the third side. I mean, that's the statement of that theorem. So similarly, I've got SM also half of QP. Understood? Now we will make use of the given
Okay.
condition. So this much result we have achieved, fine. Now come back to the given condition. So I'm given that AB by PQ is equal to AC by PR is equal to AD by PM, right? First of all, what I'm doing is I'm trying to prove the left triangles to be similar. Understood? ABD
Yeah,
and PQR.
okay.
No, not the left one. Actually, ADE
The
and the small one, right? ADE
yeah,
and this. Okay.
ADE and PMS, right?
PMS, yes. Yes, this is what I'm trying to show similar.
So why are we taking the small triangle?
Just a word I used, actually AD. Yeah, okay, I'm coming to it. You will see what I'm doing is. So
Okay.
this is actually given, right? So now AB, I can write AB to be equal to like twice of AE. Yeah, because AE is actually part of this small triangle. So this whole side
Yeah.
I can write twice of AE. And similarly PQ I'm converting into PS. So twice of PS is equal to. Now again AC I can write twice of DE, right? And again PR I can write twice of SM because I have already proved it is equal to AD by PM. Any problem?
No, no.
Yeah, because I have already proved this that they are also half. So this 2 now gone. So I am left with AE upon PS is equal to DE upon SM is equal to AD upon PM, right? Now see,
Yeah.
this all these three are the sides of these
Two
small.
AE is like AB, right?
No, actually I'm reducing this AB into AE. So when 2 is there in both numerator and denominator, so ultimately it will cancel out, right?
Okay, I understand.
This AB will convert into AE. So now you can see AE, I mean this side is proportional to this one, right? Then DE, that means this side is proportional to this SM.
Okay,
And
ma'am.
ADE is, this is proportional to PM. So all the three sides are proportional. So that means these two triangles are similar by SSS criteria, right? So by SSS criteria, triangle ADE will be similar to triangle, so PMS, right? Any problem?
No, ma'am, no,
Okay.
sorry.
Okay. So far now, if the triangles are similar, so that means the corresponding parts are also equal now. Corresponding angles are also equal. So if I'm taking this angle to be 1, so it should be equal to this angle, right?
Yeah,
Let me call it 3.
angle 3 equal to angle
Yeah,
1.
so angle 1 will be equal to angle 2, like therefore. And also this angle, if I call it 2, it will be equal to this one, 4, right? So angle 2
Okay,
is equal to angle 4. You can write corresponding parts of similar triangle.
how is angle 2 equal to angle 4? Isn't it angle 3?
Yeah. This thing actually I'm writing similarly. I mean, instead of
Isn't
repeating the
angle 1 equal to angle 3? And
sorry,
angle,
sorry, 3. Yes. Now, yeah. So angle 1 is equal to angle 3. Is that fine? Corresponding part of similar triangle.
okay,
And similarly, like if I repeat the whole process, like I do the construction on the right hand side, okay, and by repeating the whole process, I'll get angle 2 is equal to angle 4. So I will not do the proof again. I can write similarly angle 2 is equal to angle 4. Is that okay?
yeah,
So, if you will do a construction on this side, you will make a line parallel to PQ, and then again you will use midpoint and all things. So you will get this angle 2 is equal to angle 4. Clear?
okay.
So we can write similarly.
So
Uh,
how is angle 2 equal to angle 4? Like, we didn't take that triangle.
See, you can take triangle. You can start the same process as I have done, that you will first of all prove, for example, you are taking this to be, let's say, X. So you will first of all prove that X is the midpoint of PR. The same thing you will do, the whole thing, right?
Yeah,
So we will not repeat the whole proof when something is exactly similar. So we write it like this. Then up till here, we have shown that how we got this. Now,
so we
similarly,
don't
on
need to do
no,
that
no,
again.
no, you don't need to do, because you have already shown one side. You can write similarly angle 2 is equal to angle 4. So ultimately, you will get it equal. Okay.
Yeah,
So in such questions, we don't repeat it. One side we can show and the other side we can write similarly. Understood?
yeah,
Okay. I hope you have written.
yeah, ma'am.
All right. So basically, these are the two results I have got. Now I'm going to add them because I want the complete angle to be equal. Understood?
Okay, ma'am.
Okay. So we just adding. So I'll get angle 1 plus angle 2 will be equal to angle 3 plus angle 4. Right? These two equations I'm adding. So angle 1 plus 2 means angle A is equal to angle 3 plus 4 means angle P. Right?
Yeah, ma'am.
Okay. Now in complete triangle ABC, the two sides were already proportional, right? So basically this side was proportional to this and this side was proportional to this. This was given. So I have shown the middle angle also equal. So which criteria I can use now? SAS, isn't it?
Yeah, ma'am.
Yes. So at least I need one angle for that, which I have shown. So now we take in triangle ABC, the whole triangle, and triangle PQR. So what do I have now? So this much was given, that AB by PQ is equal to AC by PR, and angle A is
Into
equal to,
SAS, right?
yeah, so by SAS criteria, therefore, by SAS criteria, triangle ABC is similar to triangle PQR, right?
Yeah, ma'am.
And again, remember one thing, Martin, when you are using SAS, so that means if there are two triangles, just remember it. So if this side is proportional to this and this side is proportional to this, so you need to show this angle to be equal, right? Not the other one. The angle should be in between these proportional lines. Understood?
Yeah, ma'am.
Yeah, the proportional lines should form the arms of the angle. So that is SAS criteria. So you cannot show this angle to be equal, right? Getting it?
Yeah, ma'am.
If you are showing this, the red one equal, then SAS is not satisfied. Okay. Now last question of this exercise. Question number 15th. A vertical pole of length 6 meter cast a shadow 4 meter long. See, let me just draw a figure here. So you have a vertical pole of length 6 meter, cast a shadow on the same tower. Okay, so here somewhere you have a pole, right, Martin? Vertical pole, which is 6 meter. Cast a shadow 4 meter long. So this is casting shadow here, let's say at this point.
Yeah,
So
ma'am.
this is 4 meter long. This shadow is 4 meter long, right?
Okay.
And at the same time, a tower cast a shadow 28 meter long. So this is again a tower somewhere, which is casting the same like shadow at the same point, but this shadow is actually 28 meter, right, from the tower. Find the height of the tower. So let's say the height of the tower is X or H, you can say, right? So you have to find. So just give it some names, that A, B, C, A, B, C, and again D, E, right?
Okay.
Uh, okay. Now I need to find H. Yes, Martin. So what can I do here? Any idea? Can you guess something?
28 meters like the base and
No, first of all, think about, Martin, that which exercise you are doing and on which theorem this exercise is based, right?
okay.
Yeah, so approach it like that. You are doing triangles chapter, right?
Yeah,
So
ma'am.
first exercise was just about the definition. Then the second you have learned about the theorem, right? Basic proportionality theorem, isn't it?
Yeah.
So what was the theorem? That if two triangles are similar, uh, like the theorem was that, for example, you have a triangle and then there's a line here. Okay. So if this small
Oh,
triangle is similar to the whole triangle or something, you can write.
oh, I see. So like CE by EB
Or
equal
no, you
to,
can do one thing here, because you need H, right? You can also do one
yeah,
thing. If you show like the complete triangle ABC, for example, if you show
okay,
it similar to triangle DEC, right?
yeah,
So if you will show it similar, so that means the sides are going to be in proportion. So that means
yeah,
AB upon DE will be equal to
E
uh,
upon DE,
AB upon AB upon DE. Yeah, fine. So will be equal
But
to,
AC upon DA.
no, take the lower one because I'm not interested in this height because nothing is given. Take this side. So
Okay,
that
BC
means,
upon AB.
yes. So BC upon, no, not
BC
EB,
upon CE.
CE. Yes. So if I get this thing, Martin, so see, AB is what? H, which I have to find.
Okay,
DE is actually 6 centimeters, which is already given. Then BC length is also given 28 meter. And what is the length of CE,
4
which
meter.
is actually 4 meter, right? So I can find
Can
H,
what? Yeah,
right? So from here, my H will be equal to like 6. So 1 meter will cancel out and 1 meter will remain. So 6 meter into 28 and divided by 4. So
ma'am,
H
I have
will,
a question. Like, how did we know that ABC is
okay,
similar to DEC?
that I'm doing, right? So from here, I'll get H is equal to how much? 4 into 7 and then 6 into 7, so 42 meter. Okay, so now my objective is to prove that the triangles are similar, right?
Okay,
So you write what is given and what you have to show. Okay, nothing you show, you have to find H. So you start with these two triangles, and triangle, let's say ABC, and triangle DEC, right? So can you see something here which I
yeah.
can,
Wait, ma'am, like, how do we prove that it's like similar?
yeah, I'm proving it. So let's start. So can you see something equal here or common here?
Yeah, see, I can see.
Okay, so angle C is equal to angle C. One angle I have got. And any other angle?
And no.
Yes, there's a hint in the question. It is saying a vertical pole. Vertical means it is exactly at 90 degree from the ground. Understood?
Oh,
So that means this angle is already given to be 90 degree. And
okay, well,
similarly, the vertical tower, so that means this angle is also 90, right?
vertical tower. Did you
Uh,
mention like
yeah,
vertical tower?
I mean, tower is actually straight. It is because it is,
Ah, okay.
yeah, this question is from your, you can say everyday surrounding. So it is, we know this thing. This is the fact that tower stands straight.
So what, like
So
angle DEC equal to ABEC?
yeah, because ABC I'm writing first. So I'll write that triangle ABC is equal to triangle DEC, right? So by
Yeah,
AA criteria, the triangle ABC is similar to triangle DEC. So actually I've done the rest of the parts earlier. So from here you will get H to be 42 meters.
okay. Yeah, ma'am, completed.
Okay. Just one more question. So you have your exam tomorrow, Martin, or 28th?
28, ma'am.
Okay, 28th. Now AD and PM are medians of triangle ABC. So there's again, sorry, there is some triangle here and one more triangle here. Okay, so this is A, B, C, and this is median. Okay, D, and this is P, Q, R, and again this is median M. Okay, the triangle is actually given at this time to be similar. Triangle ABC is similar to triangle PQR. Remember the previous question where we actually proved that the triangles are similar. Yes,
Yeah, ma'am.
just now we did. And you have to prove this time that AB upon PQ is equal to AD upon PM. Okay. Hmm. So basically, Martin, if I want to show this thing that AB by PQ is equal to AD by PM, so that means AB by PQ, right, is equal to AD by PM. So ultimately, I need to show that triangle ABD is similar to triangle PQM. Getting it?
Yeah.
And from there, I can write this thing. But I'm given the complete triangle to be similar. So I'll start with this, the given condition. So triangle ABC is similar to triangle PQR. So when the triangles are similar, so I can write that, so therefore, can I write angle B is equal to angle Q? Yes.
Yeah.
Corresponding parts of similar triangle that you can write of similar triangles. Okay. And also I can write that AB by PQ is equal to, can I write BC by QR, right? Yes.
Yeah, ma'am.
Okay, because all the sides are proportional because the triangles are similar. So this thing I can write that AB by PQ is equal to, now I can write half of BC divided by half of QR. Any problem? I can just divide and multiply by half, no problem. So this will become AB by PQ. Now half of BC, can I write BD because D is the median, that means D is the midpoint.
Okay.
And similarly, half of QR will become QM because M is the median. Now simple, come back to your triangle. Now see this blue triangle. Now I all uh in this blue triangle, now I have got, from this I have got that AB is proportional to PQ, right? And I
Yeah.
have got that BD is proportional to QM. So two sides are proportional. And I have already shown here that this angle B is equal to angle Q. So which criteria is already satisfied here?
Um. SAS.
SAS, yes, exactly. PQM. So take this time. So AB by PQ is equal to BD by QM. Okay. And angle B is equal to angle Q. So by SAS criteria, triangle ABD is similar to triangle PQM, right? And when the triangles are similar, that means their corresponding sides are also in proportion. So I can write that AB by PQ is equal to AD upon PM. This is you need to prove. Corresponding parts of similar, corresponding sides of similar triangle, you can write. Okay, written, Martin.
I think.
Okay. Now in this chapter, Martin, for your exam, you have to do all the examples of NCRT, first of all.
Okay.
Yeah. And yeah, and you know, the last 5 questions usually they are, because they include some more than one concept sometimes. So do them very well, right? Both 6.2 and 6.3, because 6.1 is easy, it's easy exercise. 6.3, in fact, all the questions are good, I think. Just practice them well.
Okay, ma'am.
Uh, so Martin, let us start with coordinate geometry.
Sure, ma'am.
because that is also left. Okay. We can do one thing, Martin. I'll try to arrange one class tomorrow for you,
Yeah,
if you have time. I mean,
yeah,
because you,
ma'am, I'm free
yeah,
to.
because you have exam, so I think you should finish this chapter before your exam, because ultimately the next class will be on Tuesday, and then you will be having exam. All right, coordinate geometry. So just a quick revision, Martin. In class 9th, you have already learned about graphs. All right.
Yeah,
So
ma'am.
okay, so let me just draw a simple graph here. So basically this, if you have x-axis here, and then you have y-axis here, and then minus x-axis this side and minus y-axis this side, right? This system of coordinate is called Cartesian system. Sorry, Cartesian system, right? Because there are
Yeah,
other systems also which you will study in higher classes. So this particular xy, this is Cartesian system of coordinates. Now this you already know that you have positive numbers here, right? 4, 5,
yeah,
6. Okay, this side you have negative numbers and so on. Similarly for y-axis, 1, 2, 3, 4. So basically you have to see this on a graph paper. It's very rough drawing I'm doing. Okay, fine. So this is how the x's look like. Now, how to locate a point? First of all, if I'm calling a point, for example, 2 and 3, let's say, right?
okay,
If something is written like this in front of you, so that means this 2 is actually the x coordinate of this point, right? And this 3 is actually the y coordinate of this line, of this point, sorry, right?
okay,
Okay. So basically any point is written x and y in this form. So basically the first number is the x coordinate, the second number is the y coordinate. Sometimes it is
sure,
also called abscissa. In some question, this word might be there. So x coordinate is called the abscissa and y coordinate is called the ordinate, right? So note down these two words. Sometimes in question,
yeah, ma'am.
they may occur. Abscissa and ordinate, right? Now point 2, 3, if I want to locate this point in the graph, so how do I do? 2 on the x-axis, that means you have to move 2 distances on the x-axis and then 3 distance on the y-axis here. So that's how you locate your point 2 and 3. So this much you know, right?
Yeah,
Okay, so that's about one single point. Now if you have, for example, one more point here, let's say it is 5 and 3, 2 here. There's another point Q, which is 5 and 2. Now you need to find the distance between these 2 points. How you know how you will find the distance between these 2 points, right? So there's a formula which we will use here, which is called distance formula. So I'm not going into the proof of it. Just note down the formula.
okay, ma'am.
Distance formula is
Will
basically,
they ask for the proof?
no, it is not asked in the exam. Okay.
Okay,
So distance between 2 points A, whose coordinates are x1 and y1, right? And B, whose coordinates are x2 and y2. So any general points, right? So the formula is that distance AB. So AB means we are finding the distance. This is under root x2 minus x1 whole square and plus y2 minus y1 whole square. That's it. So the first exercise is based on this formula.
okay, ma'am.
Yeah. So it's simple exercise. I mean, you have to use the formula correctly. That's it. Let's take, for as an example, let's take one question of NCRT right here. The first
Okay,
question is that find the distance between the following point pairs, right? The first part, first question, first part. So one point is 2, 3, and the other is 4 and 1. So these are the two pairs. So first of all, you will name them. So let the points are anything, A, which is 2 and 3, and B, which is 4 and 1, so that you can write AB, right? You are finding the distance between the point A and point B. So AB will be equal to under root, again write x2 minus x1 whole square plus y2 minus y1 whole square, right? Okay, now what is x2, Martin, here?
X2 is 4.
4, okay. And x1?
2.
2 whole square plus, then y2?
1.
1, okay. And minus?
3.
3 whole square, okay. So rest is just calculation, okay? You have to do carefully. So 2 whole square and then plus minus of 2 whole square. So this is ultimately 4 plus minus 2 whole square is also 4, because minus minus will get absorbed in the square. So this is under root of 8, which you can write 2 under root 2 units, right? Is this clear how I write 2 under root 2?
Yeah.
Okay. Now, second part, you will do it. Tell me right now. Minus 5 and 7. And the other is, let's say this is A, and then your point B is minus 1 and 3. Okay, now find the distance AB quickly. Yeah, what have you got, Martin?
I'm doing one.
Yes, Martin, what have you got? Quickly tell me.
Root 32.
Okay, so under root 32. So you have to break it, right? So you do prime factorization of 32. So 2 into
Yeah.
1 and then 6, right? Then 2 into 8, 2 into 4, then 2 into 2 and 2 into 1. So that means 2 pair of 2 you can take outside the square root, right?
Yeah.
That means 2 into 2 will be outside and then 1 root 2 will remain. So that means 4 root 2. That's how you write it.
Okay.
Okay. Units, yeah, always write units because you don't know in which unit it is given. So whatever it is, units. Because this is length, right? Obviously you are using some scale, isn't it? Length can
Yeah.
only be find using a scale, right? You cannot just picturize it in your mind. You will require an apparatus to find it. So that apparatus might be of any units. It might be of centimeter, meter, inches, feet, kilometers, you don't know. So you will always write length in units. Okay. Okay. So only this much is there in this exercise. Now there's an interesting thing, Martin, here. Just see here. Because you have x2 minus x1 whole square, right? If you write it x1 minus x2 whole square, will it make any difference here? Do you think? See, it will not make any difference, Martin, because for example, you have x2 minus x.
Why would it make a difference?
Okay, so wait. It is x2 minus x1 whole square, right?
Yeah.
Okay. If you write it like this, for example, you take a -1 outside this, and then you will get x1 minus x2 whole square. Any problem?
How?
This whole square is already there. I'm not disturbing it. And then inside, I'm just taking a -1 common, right? So the minus will become plus and the plus will become minus.
Yeah.
So I have separated -1. Now, can I just break it like this? -1 whole square into x1 minus x2 whole square.
Yeah.
Yes. So -1 whole square is always 1, right?
Okay.
-1 into -1. So minus 2 times will become plus, right?
Yeah.
Okay. And you will get x1 minus x2 whole square. So 1 multiplied by anything is again x1 minus x2 whole square. So it does not matter whether you write x2 minus x1 or you write x1 minus x2, you will get the same thing. Is that okay?
Yeah.
You can check here also, for example, at this step. If you were having y1 minus y2 whole square, let's say. So what will you do? 3 minus 1 whole square, right? That means 2 whole square and then again 4. So which you are getting 4. So same thing you will get. Okay.
Okay,
So,
ma'am.
yeah, so it does not matter which point you are taking A and which point you are taking B. The answer will remain same. Okay. Yeah, so third part, can you do the third part? First question, third part.
Let me check.
Okay, let me just quickly do it. A, B, and the B is minus A and minus B. So you have to find the distance. So it's simple. A, B, just
Collinear means?
yeah, that is second question, Martin. Collinear is third question. This is first question, third part.
Okay.
See in your book. First question is having 3 parts, Martin. Yes?
Okay.
Yes. So this is the third part. Okay. Now see here, put this in the formula. So x2 is how much? Minus a. So write properly, minus a and minus a whole square. Okay. And then y2 is minus b and minus of b whole square.
Okay.
So minus a minus how much?
Minus a minus a. It's no value. So
Yeah. So what will happen now? What will I get inside bracket?
minus is the. I'm not sure.
Oh, Martin, if you have -2 and -3, what will be the answer?
-5.
-5. Okay, same thing here because you are adding, right? Both are minus. So ultimately they are adding up with a minus
So
sign.
minus 2a square
Very
whole
good.
square.
Yes. And similarly, -2b whole square. Okay. So simple minus sign will actually go with the square. So this will be 2 square into a square and plus similarly 4 into b square, right?
Yeah.
Okay, so this will be, so you can do one thing. You can take 4 outside and a square plus b square, right? So this
Okay,
under
ma'am.
root of 4 will become 2, right? So basically, it can be break like this, 4 into under root of a square plus b square, right? When the numbers are in multiplication, so that means they can be break like this. Now under root 4 is actually 2 and then under root a square plus b square. So this is the answer. Units, obviously.
Yeah, ma'am.
Okay. Now, second question you can do, it's simple, right? You have to find the distance between 0, 0 and a point. So one point is actually 0 and the other is given, it's simple. Sometimes also, Martin, like for example, one point is, let's say X and Y, okay? A. And B is 0,
Okay,
0,
ma'am.
0, 0. That means you are finding the distance of point A from origin. Understood? 0, 0 is what? Origin.
Yeah, ma'am.
Yeah, so basically this is the distance of this point A from the origin. So if I use the distance formula AB, so what will I get this time? X2 minus x1 or x1 minus x2. So that means x minus 0 whole square and plus y minus 0 whole square, right? So under root x square plus y square. So this is the distance of any point having coordinate xy from the origin. Like it can be taken as a formula also. But I think you don't have to remember so many formula because you already know the distance formula, you can do it, right? So if
Yeah,
one,
ma'am.
yeah, if one point is origin, so simply the distance is under root x square plus y square. You can remember it also. Now third question, come to third question. Determine if the points are collinear. Collinear means they all lie on the same line. For example, you have a line, one point can be here, another can be here, another can be here, anywhere they can be, A, B, C, right? Now you have to show
Yeah,
that
ma'am.
the 3 points ABC, for example, any coordinates are there, ABC, they are collinear. So, Martin, if they are collinear, that means the distance AB plus BC should be equal to AC, right?
Yeah.
Yeah. Or the points can be like this. I don't know where it can be like this. Yeah, I don't know where is A, where is B. I can name it any time, anyhow. So this time CA plus AB will be equal to CB, right? So
Okay.
basically we have to show that we will find the distance between all the points. We will find AB, we will find BC, we will also find AC. And if we see that the sum of the two distances is coming out to be equal to the third one, so that means the points are collinear, right?
Okay.
So that's what we will do. You will find the distance. So just a hint I'm giving, you will find AB, right? Then you will find BC, then you will find AC. And then you will see whether sum of two distances is equal to the third distance. Or shall we do it? Let's do it. One question.
Yeah.
So I'm naming some points. A is 1 and 5, and B is 2 and 3, and C is -2 and -11, right? So quickly find AB. So write the formula first of all, x2 minus x1, that is 2 minus 1 whole square plus y2 minus y1, 3 minus 5 whole square, right? So this is 1 whole square plus 3 minus 5 means minus of 2 whole square. So this is 1 plus 4. This is under root of 5 units, right?
Yeah, ma'am.
Similarly, find BC. Again, x2 minus x1, that means -2 whole square plus -11 -3 whole square. So this is like minus of 4 whole square plus minus of how much? 14 whole square, right?
Yeah.
So 4 into 4 is 16 and 14 square is I think 2, no, 169 is 13, so 196. Yeah, perfect squares I think you should remember, you are studying them from class 7th or 8th. So perfect squares, at least keep them on your tip. So 14 square is 196. So on adding it you will get what? 6 and 6 12, then 0 and 2 0 2 2 no 2 1 2 I think. Oh, wait, yeah, 6 and 6 12, then yeah, so 2 and 2, right? Under root 2 and 2 units. Now you can see, Martin, 2 and 2 is an even number, isn't it?
Yes, ma'am.
So that means there is a factor of 2 here. So we will do prime factorization and check. So 2 1 2. So 2 into 1 0 6. Then again 2 into 5 and 3. Now 53 is a prime number. So that means 1 2 can come outside because you have a pair. So this will be 2 under root of 53 units. Fine.
Yeah, ma'am. Yeah, ma'am.
Okay, find AC now very quickly. So -2 -1 whole square plus -11 -5 whole square. Please write the formula. I'm not writing it. So -3 whole square plus minus of 16 whole square. Okay, so 3 into 9 and 16 means 15 is 225, 16 is 256, right? Yes. Now 9 and 6, 15, then 6 and 2, 265. Now 265, you can see, Martin, it is divisible by 5, right? So let me try whether I have 5 here. So 5 into 5 is 25, then 15, that means 3. Okay, so it is 5 into under root 53. Yes.
Yeah.
So Martin, now see here, this is 2 under root 53. Now see, under root of 4 is actually 2, right? And under root 5 will be 2 point something, like slightly higher than 2. Got it? Got it?
Yeah.
Yeah, so this number AC is actually slightly higher than BC. Getting the point?
Okay.
Yeah. So, but in this question, your AB plus BC is not coming out to be AC, right?
So they are not wholly.
See, ultimately from here, this is, as I told you, this is 2 point something. You can check from the calculator also. If you have under root 5 is how much you will get. Yeah, 2.23, Martin, right?
Yeah, ma'am.
And this under root 5, that means again 2.23 units. Getting it? Okay. So now if you do AB plus BC, you can see here, AB is something 2.23 and plus BC is 2 under root 53, right? And AC is 2.23 under root 53, right?
Yeah.
So that means, now can you see this is higher? Actually, in 2 under root 53, you are adding some 2 point something. So this complete side will actually become greater than this thing. Getting it?
Yeah, ma'am.
Because see, between this and between this, there is a very slight difference. Only 0.23 difference is there, right?
Yeah, ma'am.
But you are adding 2.23 here. I mean, 2 extra you are adding. Understood?
Like the value is less to add, so it's not.
So ultimately, your left hand side is going to become greater than your AC, right?
Yeah.
So you have to observe it carefully here. So all right, rest of the questions we will do in the next class. You will receive a message, Martin. Tomorrow at what time you are free? In the evening or in the morning? Do you have school, Martin?
No, ma'am. I don't.
So can you come for the class in the morning also?
Morning as in like what time?
Okay, you tell me when you are comfortable.
Is 1 o'clock okay?
1 o'clock. That means India. India, it's 3:30, right?
Yeah.
Can we have a bit earlier, Martin?
So like 11 o'clock,
Mm,
1:30 there,
1:30 here. 1:30.
12:30. Never mind. It's 12:30.
You are in UAE.
Yeah.
Oh, okay, UAE. I think yeah, that's fine.
Okay, ma'am. Just
12:30. Yeah.
just confirm with them. Yeah.
Okay, so I'll just confirm with the team the
Okay.
timings. Then we will have a class.
Yeah.
Okay. Thank you, Martin. You
Thank
can
you,
leave.
ma'am.
Okay. Bye. Hello, Rida. Can you hear me now?
Yes, ma'am.
Okay. Sorry, I was just winding up the previous class. Okay. Hamna has not joined. Oh, she's having an exam today, I think. Yeah. 26, she's having exam. Let me check. No, Rida, you are having exam tomorrow, right? Yes, Rida, can you hear me?
Yes, ma'am.
Do you have exam tomorrow?
Yes, ma'am.
Okay. So Rida, first of all, tell me, do you have any query or any doubt from the previous exercises?
Which chapter?
No, I'm asking because you have an exam tomorrow and coordinate geometry is not coming in the exam. So till triangles, is there any doubt, any confusion in any question?
I have confusion in 4th chapter.
That is what? Quadratic equation.
Yes.
That we have not done actually. Okay, quadratic equation, just tell me, wait. Only exercise, I think 4.1 is coming, right?
1, 2, and 3.
1, 2, and 3 is coming. Okay. So tell me where you are having problem.